What if the universe isn't silent? What if everything, from atoms to galaxies, participates in one vast harmonic structure? Welcome to the Harmonic Continuum. Look up on a clear night. You see a vast dark canvas. It is sprinkled with countless points of light. You might feel a sense of your own smallness. You might feel a deep and profound wonder. Now let us consider a beautiful idea. Imagine that all of this silent majesty is making music. Imagine that the planets, the stars, even the tiny atoms are all moving together. They are like the different parts of a grand cosmic orchestra. This is the idea we are going to explore. The thought that everything, at its core, is simply vibration, a universe that sings. A vibration is a simple thing to understand. It is just a motion. It is a movement back and forth around a central point. Think of a string on a guitar. When you pluck it, it moves so fast it becomes a blur. That rapid movement pushes the air and creates a tone. Think of the tight skin of a drum. When you strike it, it moves up and down. That motion creates the deep pulse of a beat. A tuning fork, when tapped, shakes with a steady, pure tremor. Its vibrations create a single, clear sound. These are vibrations we can easily see and hear in our world. This same simple principle works across all scales of the universe. It works on scales so large they are hard to imagine. Planets move in their great, sweeping paths around their stars. They create immense, slow rhythms that are measured in years or centuries. Their orbits are like the slow, powerful drumbeat of a cosmic symphony. Even stars themselves are not static. Many stars pulse and shine with a regular, observable rhythm. They swell and shrink, growing brighter and then dimmer. Some stars, called pulsars, spin with incredible speed, sending out beams of light like a lighthouse in the heavens. When truly massive objects meet, they can shake the very fabric of space-time. Imagine two black holes spiraling into each other for millions of years. Their final, cataclysmic merger sends out ripples across the cosmos. These are called gravitational waves. They are not waves moving through space, but waves of space itself. They stretch and compress the universe as they pass. These waves are like the deepest, most powerful notes imaginable. They are the bass tones of the cosmic song, carrying the story of immense events across billions of light years. The cosmos is not silent. It is filled with motion, you know? Now, let us journey from the immense to the infinitesimally small. Let us shrink down, past what our eyes can see, into the world of atoms. Atoms are the tiny building blocks of everything you see around you. They are the chairs, the air, and your own body. At the heart of each atom is a nucleus. Around this nucleus, electrons move in a cloud of probability. They exist in specific energy levels, like rungs on a ladder. When an electron jumps from a higher level to a lower one, it releases a tiny packet of light, a photon. This light is a vibration. It is a wave of energy. This release of light can be seen as a musical event. It is like a single, pure note being played by a tiny subatomic instrument. In physics, we understand these fundamental actions as waves. These waves are not so different from the waves on a pond or the sound waves from a speaker. They all follow a set of simple, elegant rules. Waves have a certain speed at which they travel. They have a wavelength, which is the distance from one peak of a wave to the next, and they have a frequency, which is the count of how many peaks pass a point every second. The concept of frequency is key to this entire idea. For sound, a high frequency gives us a sharp, high-pitched note. A low frequency gives us a deep, rumbling bass tone. Our ears interpret these different rates of vibration as different sounds. Light works in precisely the same way. The only difference is that our eyes are the instruments doing the sensing. What we perceive as different colors are simply different frequencies of light. Red light has a lower frequency. Violet light has a much higher frequency. The entire rainbow is a spectrum of visible light frequencies, just like a musical scale is a spectrum of audible sound frequencies. So, from the slow waltz of planets to the rapid tremor of an electron's leap, the universe is governed by vibration. The same mathematical language describes the ripple on a pond, the sound of a violin, and the light from a distant star. This unity is one of the most profound discoveries of science. It suggests that the same fundamental patterns repeat themselves over and over, at every scale. It is as though the universe has a deep, underlying structure. A structure that is not just mathematical, but also deeply musical. A structure we can begin to understand by listening. Well, there is a special kind of pattern that waves can create. It is called a standing wave. Unlike a wave that travels from one place to another, a standing wave appears to vibrate in place. Imagine plucking a guitar string. It moves up and down so fast that it creates a stable, lens-like shape. It doesn't look like a wave moving along the string. It looks like the whole string is vibrating as one unit. That is a standing wave. The skin of a drum also creates beautiful, complex patterns of standing waves when it is struck, forming nodes and antinodes where it moves the most and the least. These stable patterns are not just for musical instruments. We see them in nature all around us. In space, vast clouds of gas and dust that orbit young stars can be shaped by these very principles. The gravity of the star and the pressure of the gas can create regions where standing waves form. These waves can create patterns of light and dark or areas where matter clumps together. These patterns might even be the first step in the formation of planets. The clear, stable notes of a musical instrument are a direct consequence of standing waves. They are what make a definite pitch possible. This brings us to another word that is vitally important: resonance. Resonance happens when one vibrating object causes another object to vibrate with much greater energy. It is about matching the timing or frequency. If you push a child on a swing, you instinctively learn to push with the right rhythm. You match the natural frequency of the swing. This makes it go higher and higher. A singer can hold a note that matches the natural resonant frequency of a wine glass. The glass will begin to vibrate, and if the note is loud and pure enough, the glass can shatter. In the cosmos, resonance is a powerful architect. It can sculpt the rings of dust and ice around a planet like Saturn, creating sharp gaps and bright bands. It can also guide the orbits of planets, locking them into simple mathematical ratios with each other. This is called orbital resonance. For every 2 times one planet circles its star, its neighbor might circle exactly 3 times. This gravitational timing, this resonance, creates stability and order within a solar system. Just as resonance makes a concert hall fill with rich sound, it helps to build and maintain the structure of the cosmos. Behind all of this beauty, there is a quiet and elegant language. It is the language of mathematics. Simple-looking formulas and equations describe how all these waves behave. They are the blueprints for the universe. One equation connects a wave's speed, its length, and its frequency. Another describes how a force creates motion and vibration. Gravity. Electromagnetism. Albert Einstein's famous equation, E equals mc squared, even reveals a deep connection between energy and mass. It tells us that matter itself is a form of concentrated energy, a frozen vibration. These equations are not cold or abstract. They are powerful tools that allow us to see the world in a new way. They allow us to create images and sounds that are a true representation of nature's processes. When we make a film about the cosmos, these equations can be visualized. They can float in space like constellations of light. They can appear as shimmering lines of code, or soft, glowing numbers overlaid on an image of a galaxy. This is not just for decoration. It is to show the viewer that underneath the chaos and the beauty, there's an exquisite and understandable order. Sound is something we feel in our bodies. Music has a direct line to our emotions. It can make us feel joy, sadness, a sense of awe. A composer can use this power to help us connect with these grand scientific ideas on a deeper level. If the universe truly operates on principles similar to music, then music can be a bridge to understanding. A slow, majestic swell of orchestral strings can suggest the immense scale of a spiral galaxy rotating over millions of years. A single, pure tone from a flute can represent the pulse of a distant star. The ethereal sound of a choir can mirror the complex, overlapping patterns of waves in a nebula. The soft, delicate notes of a piano might hint at the quantum leap of an electron inside an atom. Making these connections is not about being literal. It is about using the emotional language of music to translate the intellectual beauty of physics. This approach can make a scientific story feel both deeply true and profoundly moving. It allows us to experience the poetry of reality, not just the facts. It helps us feel the harmony that science has uncovered. The idea that everything is vibration is not a scientific claim that the universe is literally a song you could record. It is a perspective. It is a powerful metaphor for understanding the patterns and order that science has revealed to us. It is a way to connect two of the most powerful human endeavors: the search for truth in science, the search for meaning in art. Seeing the cosmos as a musical entity helps us feel a more personal connection to it. It transforms the cold, distant facts of physics into a source of wonder and joyful learning. This perspective invites us to engage with the world in a new way. It invites us to listen more carefully. The next time you walk through a quiet place, pause for a moment. Listen to the sound of the wind moving through the leaves. Listen to the rhythm of your own breath, the beating of your own heart. As you listen, think of the stars, burning billions of miles away. Think of the atoms, vibrating in the very air you breathe. Think of the simple elegance of a guitar string, the complex dance of waves upon water. The same fundamental rules are at work in all these things, the same principles of vibration, frequency, resonance. Perhaps the universe is not just a collection of matter and empty space. Perhaps it is a dynamic, interconnected field of motion and tone. Perhaps harmony is not just a concept from music, but a property woven deeply into the very fabric of reality itself. We are part of this cosmic orchestra. The story of the universe is a story of vibration. All you have to do is listen. Perhaps music is more than an art. Perhaps harmony is woven into the very fabric of reality. The Harmonic Continuum invites us to hear the universe in a new way. Subscribe for more Harmonic Continuum minutes and discover where music, science, and the cosmos meet.